Okay, and like I left off with on the last video, when we make our table for 6 times 12 is 72, we find that 9 and 8 are our two factors that give us 1 when we subtract. So by subtracting, we know that one of our factors of 9 and 8 has to be positive and one of our factors has to be negative. Because we're trying to add to a plus 1e, a positive 1, we are going to make our 9 positive and our 8 negative. So 6e squared plus 9e minus 8e minus 12. Now we're going to continue by factoring, by grouping. So 6e squared, we know that that's 3 times 2, e and e. 9 is 3 times 3 with an e. So we have a 3 in common and also an e in common. So my GCF is 3e. What I'm left over with is 3e plus, 2e plus 3. Okay, looking at the other side of my four-termed polynomial, I have negative 80 and negative 12, so I can write negative 8e as negative 4 times 2e, and negative 12 is negative 4 times 3. And of course, I can write 8 as 8 times 1, and I can write 12 as 12 times 1, or 2 times 6. But I'm looking for the GCF. I'm looking for the greatest common factor, the number that is the biggest that's shared between the two of them. So that's why I chose to write 8 as 4 times 2, because we have a negative 4 that's in common. I'm left with 2e and then a positive 3 again. So my two factors are 3e minus 4 and 2e plus 3. Okay, number 7 is just a GCF problem. I know because I have multiple variables. I only have a binomial, so I can't be making all this tables and everything because I don't have an A, a B, and a C. I don't have a variable that's squared, a linear variable, and a constant. So I'm just looking for greatest common factor. I know that 16 is 16 times 1, and 2 times 8, and 4 times 4, and that 40 is 40 times 1, and 20 times 2, and 4 times 10, and 8 times 5. Did I get everything? But I'm looking for the greatest common factor. So the biggest number that's in both of these lists, of course, is 8. W to the 7th power means I have 7 W's. 4 J's. W to the 3rd power means I have 3 W's and just 1 J. So when I'm looking for my GCF, my greatest common factor, I'm also going to look at my variables. So how many can I circle on both sides? 3. How many J's can I circle? 1. So my GCF is 8W cubed J. Then what I'm left with is 2, 4 W's, and 3 J's. 2, 4 W's, and 3 J's. Minus, I'm left over with a 5, and actually no variables. Okay, slope. Find the slope between the 2 points. So I'm going to use my slope formula. y2 minus y1 divided by x2 minus x1. This is x1, y1. This is x2, y2. So first I have y2 minus y1 divided by x2 minus x1. 1 minus 6 is negative 5, and negative 3 minus 8 is negative 11. A negative divided by a negative is a positive. From the graph, I can just count. That's nice and easy. I can count down 1, 2, 3, 4, 5. And I can go over 1, 2, 3, 4. 1, 2, 3, 4. So down 5, to the right 4. My x-intercept doesn't look like it goes through exactly, so I'm going to say maybe negative 0.9 because it's not quite at negative 1. But then my y-intercept, I know that's exactly going through at negative 1. Remember, with an x-intercept, you're only moving side to side, so we only have an x value. The y value is 0. And in a y-intercept, it's the opposite. We're only moving up and down. So in an ordered pair, x comes first, then y. Okay, from our table. So we can use any 2 points, but I'm just going to look at this table as a pattern because it looks like I can see that we're going down by 2, down by 2, down by 2, down by 2. And my x's are going up by 4, up by 4, up by 4, up by 4. So if I'm looking at my change in y divided by my change in x, my change in y is negative 2. My change in x is 4, reducing that fraction, negative half. Nice and easy to find the intercepts here because I'm looking for zeros in my table. I've got one there and one there. So x-intercepts happen when my y is 0. So my x-intercept is going to be at 8, 0, and my y-intercept is going to be at 0, 4. All right, solving equations. So my goal here is to get the variables combined because they're all p's. Combined and then isolated. I want to get the variable all by itself. So first I'm going to take care of my parentheses. I have 12p minus negative 5p plus 6. So I have to distribute this negative and I have to subtract both terms in my parentheses. So I have 12p minus 5p, which is really plus 5p, and then minus positive 6. Combining my like terms gives me 17p. Now I have a variable and a constant on both sides, so I'm going to start doing inverse operations. So I have a positive 13p, so I'm going to subtract 13p from both sides, giving me 4p minus 6 equals 2. Next, I have a minus 6, so I'm going to add 6, the opposite, to both sides, and I get 4p equals 8. And then last, I have multiplying by 4, so I'm going to divide by 4, and I get that p is equal to 2. Now, what I can do is I can take my calculator and I can show that this is the solution. So if I have my calculator right here, okay, let me zoom out here. Okay. So I have 12p minus parentheses negative 5p plus 6. Okay. Now we should get the same thing on the other side. So 13p plus 2 equal, same thing. Awesome. I can always check my work. Excuse me. Okay, next, I have just some distributive property over here. So I'm going to distribute my 3 to both terms. So 3 times negative 2d is negative 6d, and 3 times 5 is 15. I'm going to do the same thing on the other side. I have a 2 that needs distributed to both of these terms of d plus 4. So this becomes 2d plus 8 equals 35. Again, I'm going to combine my like terms when they're on the same side of the equal sign. So negative 6d plus 2d, negative 6 plus 2 is negative 4. And I'm also going to combine my constants. So I'm going to combine my 15 and my 8. I'm going to add those together. So 15 plus 8, oopsies, is 23. Inverse operation, subtract that 23. I get that negative 4d is equal to 12. divide by -4, and D equals -3.